Hello students, for this session, we will be talking all about trigonometric functions of the angles of a right triangle. So, later on, I will be giving you the 6 trigonometric functions. But before that, look at this diagram first. It is a right triangle whose sides are denoted by A, B, and C. Usually, class, we can define the 6 trigonometric functions through an acute angle. So let's say this is an angle here. So in studying the 6 trigonometric functions, we just need to remember 3 important sides. So if this is our basis, this angle is our basis, class. The opposite side is this. Its opposite is this. And its adjacent side is this. And as usual, the longest side is the hypotenuse. So let us try to define the 6 trigonometric functions of this angle here, angle theta. So first we have the sine theta or the sine function, cosine function, tangent function, cosecant function, secant function, and cotangent function. These are the 6 trigonometric functions. And we are to define the 6 trigonometric functions through this angle here. The first one is the sine function. So sine theta is equal to side opposite of that theta all over hypotenuse. So side opposite B over hypotenuse C. So B over C. That is the first trigonometric ratio. The second one is the cosine function. So we have cosine theta is equal to side adjacent, so A, over hypotenuse, C, so A over C. Next, the tangent, we have opposite side, B, over adjacent side, A, so B over A. Now, we can easily get the 3 other functions because these are the reciprocal functions of the 3 other functions here. The reciprocal of sine function is cosecant function. The reciprocal of cosine is cosecant. The reciprocal of tangent is cotangent. So in that way, we can say that cosecant theta is C over B. Why? It is the reciprocal of sine. So C over B. And also, the reciprocal of cosine is secant theta. So we have C over A. And the last function is the cotangent function. The ratio here is A over B because it's the reciprocal of tangent. Now we have a device used to remember it easily. We have the SOHCAHTOA. So, meaning sine equals opposite over hypotenuse. Ka means cosine equals adjacent over hypotenuse. And TOA means tangent equals opposite over adjacent. Okay. Consider this diagram. So we have this. Find the 6 trigonometric function values of alpha and beta. Let's have first the alpha. So I repeat that so means sine, opposite over hypotenuse. So the opposite of alpha is 24 and its adjacent is 7, while in the beta angle, in beta, its opposite is 7 and the adjacent is 24. Okay, so let's continue. So cosine function, so cosine alpha is equal to adjacent over hypotenuse. So adjacent is 7, hypotenuse 25. The tangent theta, so TOA, that means tangent equals opposite over adjacent. So its opposite is 24, its adjacent is 7. Here. So as I said a while back, we can easily get the other three functions because they are just the reciprocal of these three functions here. So the reciprocal of sine theta or sine alpha is cosecant alpha and it's equal to 25 over 24. That's the reciprocal. The reciprocal of cosine alpha is secant alpha, so we have 25 over 7. And last, the cotangent, we have cotangent alpha is equal to 7 over 24. How about the 6 trigonometric function values of beta? So, if this is the angle here, its opposite is no longer 24. It must be 7. And its adjacent side is 24. This. So, let's move on. Sine beta is equal to opposite 7 over hypotenuse 25. And then cosine is adjacent over hypotenuse. So adjacent side is 24 and the hypotenuse is 25. So 24 over 25. And tangent function, so we have tangent beta equals opposite over adjacent. So we have 7 over 24. So as usual, we can get now easily the three other trigonometric functions because they are just the reciprocal of sine, cosine, and tangent respectively. So cosecant beta equals 25 over 7, secant beta equals 25 over 24, and cotangent beta equals 24 over 7. Okay. What if you are only given one trigonometric function and you are to find the remaining trigonometric ratios? How do we do this? First, let us first draw a right triangle. And this is the angle here. We can write it here or either here. So let's say this is the angle here. Now, you have to remember the device, the SOHCAHTOA, that is the sine function here. So we have opposite and hypotenuse. So its opposite is 5 and the hypotenuse is 13. Now, to get the other side, we can use the Pythagorean theorem. Let's denote this as x. So we have 13 squared equals x squared plus 5 squared. So simplifying that, we have x equals 12. So here, the third side is 12. So we now have the adjacent side. So cosine alpha now is equal to 12, that is adjacent side, over hypotenuse 13. So 12 over 13. the tangent alpha is equal to opposite, that is 5, over adjacent 12. So 5 over 12. Now, the reciprocal of sine theta, or sine alpha, I should say, is cosecant. So we have 13 over 5. The reciprocal of cosine is secant. So secant alpha is equal to 13 over 12. And the reciprocal of tangent is cotangent. So cotangent alpha is equal to 12 over 5. Thank you.